Hello, welcome to module 8. So in this module, we're going to discuss one element that is important in the software testing and test case design, which is called coverage criteria. Okay. But before beginning about coverage criteria, I want to discuss about model-driven test design first. And then we will discuss what is coverage criteria, how it is used, what are the benefits, when to use it, and how to use it. Okay. And we might discuss about what are the existing criteria and how they are categorized, and which criterion should be used, when and why and how. Okay. So let's get started with the model-driven test design. In model-driven test design, we would do as follows. So first, you must change the software into some of the model or some of the structure. So instead of looking at the software as is as a source code, you change it into some kind of other representations. And then you think about the test requirements, which mean what you need to cover to be able to fully test it or to satisfy the test criteria here. And then you refine the test requirements and the test spec that you have. This is the part that we call the test design phase. Okay. So after that, we go down to the implementation level. So the one that I just told before is in the design abstraction level. You don't care about the software. You care about the model that represents the software. But after we have refined the test spec, the test cases, then you come down to the implementation level. You think about what is the input value, what are the test cases, and you develop the test script. This is the stage that we are doing test automation. And then you execute the test, you get the result, and then you evaluate the test, whether it passes or fails. Okay, this is the new way of thinking about test cases, that you don't only consider the code, but you transform it into some kind of models. So the notions in testing also change. The old view that I already presented to you before, like the V model, think about the test based on the level of the development. Like implementation, you have unit tests. Detail design, we have module tests. Subsystem design, we have integration tests. Architectural design, we have system tests. And requirements, we have acceptance tests. But the new view will based on the structure and the criteria of the software that you are testing. So the first one that we already discussed is we think about the input and we use the input space as the model for our software. So we see the software as a set of parameters and we think about their input spaces. The second view is we change the software into graphs and then we define the test based on this structure. The third view is we look at the software based on their logical expression and then we decide the test accordingly. Or lastly, if we go down to the lowest level, we see the code as syntax structure and then we define the test case accordingly. In whatever level that we think about, the test design is pretty much the same at each phase. So only the structure is different. Only choosing of the value and the automation of the test is different. So then we need to just define the structure of the software, and then we find a way to cover the structure that we define as much as possible. This kind of structure, we can extract from many of the artifacts that we have in the software. So for example, graph, we can get it from the source code itself, from UML use cases, or from the finite state machines. For the logical expression, we usually derive it from the source code statement, like in the if-else statement or in the for loop header. Or you can think about the guards on the transition in the state machine diagram, or some conditional in the use case and so on. Okay. So that is the model-driven test design concept. And after this, we're gonna keep discussing several techniques like graph-based technique, logic-based technique that rely on such model-driven design. Okay, so next, let's move on to the concept of coverage criteria. The coverage criteria comes in because we cannot cover all the possible inputs for testing any specific piece of software. Let's say if we have this very simple method again, it is a method called isLeap, and it accepts one integer of a year, and then it gives the Boolean value whether this is a leap year or not. So the computation follow the normal concept of a leap year. If it is divisible by 4, then it's a leap year, but if it's not, then it's not a leap year. If it is divisible by 400, then it is a leap year. But if it's divisible by 100 as well, then it is not a leap year. Okay, so with this, just the year as an input, we could have 2 to the power of 32 possible values. That is already pretty huge. And we cannot cover all the possible input for this given program based on some limited time. So how do we do? It is impossible for us to cover all the input. So we need to have some rules to help us decide which input to enter. And we know that we have already tested enough. So when to stop, right? So this concept of coverage criteria is used to describe a finite subset of test cases. Okay, finite subset of test cases. And usually it is by performing some kind of partitioning. So we divide the input space into partitions so that we can maximize the number of faults. And then we select only the subset from those partitions. Like from the concept of input space partitioning, we have a vast amount of values that we need to cover. We use characteristic to create partitions, and then we select representative from those partitions. So by doing that, we are creating a finite subset of test cases. Okay. So the benefit of doing such coverage criteria is, first, adequate. It helps us to know whether we got enough tests. The second one is that it guides us to the part that needs to test more. And the last one is it allows automation. So we can generate tests that we can automatically check whether it satisfies a test requirement or not. So in order to perform such coverage criteria, we need to know some of the terminology. Okay, so the first one is called coverage criterion. A coverage criterion is a rule or collection of rules that you impose the test requirement on a test set. What is a test requirement? A test requirement is a specific element of software artifact that the test case must satisfy or it must cover. So we define this kind of requirements so that we know whether the test cases that we create fully satisfy the requirements or not. And the type of test requirements that is needed depends on the specific artifact of the software that you are testing. If you go to the source code level, it might be lines or statements. If you go to graph level, it might be the number of nodes or the number of edges. If you do the logic level, it might be how many combinations of potential branches in the logic that you cover, so on and so on. Okay, I would like to also review the other two terminologies that we have discussed before. So test case is a set of test input, some execution conditions, and the expected result. Okay, we use it to verify the correctness of the system. And a test set is a set of test cases. So if you have more than one test case, you group them together, we call it a test set. I would like to explain the concept of coverage criteria. by having this very simple example of candies. No, let's call it a blow pop coverage. If you have these kind of blow pop candies, the blow pop candies can be classified into two properties. First, if we think about its flavors, it might have cherry flavor, blue raspberry flavor, strawberry flavor, sour apple flavor, grape flavor, and watermelon flavor. But if we look at the color property, they might have only four groups, which is red, include cherry, strawberry, and watermelon. Blue, that is blue raspberry. Green, which is sour apple. And purple, which is grape. So by knowing that the candies have the following values for the flavors and the following value for the colors, we can define the following criteria. The first one is criteria C1. Taste one blow pop of each flavor. So if we say that the criteria is we must taste each flavor, then we need to check whether we test cherry already. Have we tested raspberry already? Have we tested strawberry, sour apple, grape, and watermelon already? Another kind of criteria that we can ask is C2. Taste one blow pop of each color. So if we think about the color, we check whether we test the red color, we test the blue color, we test the green color, and we test the purple color or not. Okay, so by having these criteria, I can derive the test requirements. So for criteria C1, I say I want to test all the flavors. So my test requirement needs to contain all the flavors available for the candies, which is TR1 cherry, TR2 blue raspberry, TR3 strawberry, 4 sour apple, 5 grape, and 6 watermelon. So this is a set of the test requirement for my coverage criteria number 1. But let's say if I choose the criterion of the color, I would have the test requirement for C2 as follow. I would need to have TR1 covering red color, TR2 blue color, TR3 green color, and TR4 purple color. The set of test requirement will be smaller, having only these 4 elements: red, blue, green, and purple. Okay, this is why depending on the coverage that you set, coverage criteria that you set, you get a different set of test requirement. What about if we have a source code? If we have a source code like this, a method called num0, you have an array of int x. We check, okay, we go to check whether each element has 0 or not, and then you count it, and then you return. This has totally of 5 lines, okay? If we have the test requirements, the criteria is we need to cover all the lines. Then the test requirement will include line number 1, line number 2, line number 3, line number 4, and line number 5. But if we think about the branch coverage, we need to look at all possible routes that the program can go. So the first route is if x equals null, it will throw null pointer exception. The next one, if I less than x dot length, it will go out of the loop. I'm sorry, for B1, we have 2 sides. The first one is when I is less than x dot length, and the other side is when I still more than or equal x dot length. And for B2, it also has 2 sides, 2 branches. If xi equals 0 and xi does not equal 0. So with this kind of test coverage, you would have 1 branch from this one because it has only 1 way, and 2 branches from B1, okay, and another 2 branches from B2. You can see that depending on what kind of model that we choose, what kind of criteria that we choose, it affects the set of test requirements. So what is coverage? Okay, we talk about the criteria, we talk about the test requirement. Now we talk about what is coverage. The coverage is by giving a set of test requirements TR for any coverage criterion C, and we have a test set T. The test set T will satisfy the criterion C if and only if every test requirement in TR, there is at least one test in T that satisfies such TR. Might get a bit confusing for you. I hope it's not too confusing. So what it means here is that if you have a test set T and you have test requirement, a set of test requirement, if you pick any test case from that test requirement, and you can guarantee that all the test requirement at least covered by one of any test cases, then you got the coverage. Okay. Let me show you some basic example. You have T and you have test requirement here. So the test case consists of T1, T2, T3. You have the test requirements TR1, TR2, and TR3. The first test requirement is satisfied by T2. The second test requirement is satisfied by T1. And the third test requirement is satisfied by test case T3. So we say that we got 100% coverage on this test requirement, giving a test set TC. Okay. There are two types of test set that is possible, depend on the test requirement that you have. The first one is called a minimal test set. So a minimal test set is when you give a set of test requirement and a test set T, you satisfy all the test requirements. That test set T is minimal. If you remove any single test from T, will cause T to no longer satisfy all the test requirements. So if you already have a test set T and that test set cover all the test requirement already, you remove anything out, it will no longer satisfy. We call that as a minimal test set. But the next one is called a minimum test set. So the definition is slightly different. Sorry. For a minimum test set, giving a set of test requirements TR and a test set T. The test set T also satisfy all the test requirements. It will become minimum when you can't find any smaller set of tests that also satisfy all the test requirements. Okay, so sometime or most of the time, the minimum test set will also be the minimal test set, but this might not be true all the time. Okay, so this one is stricter, no smaller test set that is satisfy the test requirement. So let's continue the concept of blow-pop coverage. So if we have these two criteria, the flavor criterion and the color criterion, we have the test set of T1. Let's say I have the test set T1 of 1 cherry, 1 blue raspberry, 3 strawberries, 1 sour apple, 2 grapes, and 4 watermelon. We check whether it satisfies any of these criteria or not. So let's check. If we look at the flavor criterion, we pick 1 cherry, so we already satisfy this one. We pick 1 blue raspberry, it already satisfy this one. We pick 3 strawberries, it satisfy this one. We pick 1 sour apple, it satisfy this one. We pick 2 grapes, it satisfy this one. And we pick 4 watermelon, it satisfy this one. So the answer is yes. Does it satisfy C2? We pick cherry, it satisfy red. I pick blue raspberry, it satisfy blue. I pick sour apple, it satisfy the green. I pick the purple, it satisfy purple. And the other, like strawberry, will double satisfy the red, and the watermelon will double satisfy the red again. Okay, so here we also satisfy C2. If I have another test set called T2, let me remove all of this. If I have another test set T2, it is 1 blue raspberry, 1 sour apple, 2 grapes, and 3 watermelon. So let's see whether it satisfies C1 or not. I have 1 blue raspberry. I have 1 sour apple. I have 2 grapes, and I have 3 watermelons. You can see that it's still not satisfy C1 because you have cherry and strawberry that is not satisfied. So let's see whether it satisfies C2. I have 1 blue raspberry, so it gets blues. I have 1 sour apple, so it satisfies green. I have 2 grapes, so it satisfies purple. And I have 3 watermelons, so it satisfies red. Interestingly, this test case T2 still satisfy the color criterion, but it doesn't satisfy the flavor criterion. Okay, so depending on which criteria that you have, the test case might or might not satisfy such criteria. Okay. Sometimes you don't get full coverage. Okay, and it is expensive to satisfy fully coverage criterion. So we get some compromise by we achieve some certain coverage level. So this is called a coverage level. When you got 100%, we can say that it covers or it get full 100% coverage. But if you don't get full coverage, we can compute the amount of coverage level. So the coverage level is the number of test requirements that are satisfied by T in the TR divided by the size of the TR. So if you have this, for example, this case, you cover 1, 2, 3, 4 out of the total 6. So the coverage criteria is 4/6. And the second one, you cover everything. So in this case, you get 4/4. Okay. So we can compute this kind of coverage level, and we set what we want to compromise. We want to do something to the level of 60%, 80%, 90%, so on and so on. And we stop there. So I already showed this, right? So if you check the first one, you get 100% coverage because it satisfies both C1 and C2. The first one has 6 colors. You cover all of them, so it's 6/6. The second one has the first one has 6 flavors. The second one has 4 colors, and you cover 4 of them, so that's 100% coverage. So for T2, the first one, it has 6, you cover 4, so you get about what is 4/6? Just a moment. 66%. Okay. And this one, you get full coverage again. So you have 100% coverage. All right. By having this, you can compute the level of coverage. So we don't need to have 100% coverage all the time. In some cases, the test requirements can be infeasible, which means it cannot be ever satisfied. And in that case, you will never reach the full coverage because you cannot find any test case value that's gonna satisfy the test requirement. For example, if you have some dead code that the program cannot reach that statement, it is pretty sure that you cannot cover 100% line coverage. And this is very difficult to find. Okay, so usually we don't know whether we're gonna get any infeasible test requirement, and we might compromise at some level of coverage criteria level, like 90%, 95%, or 80%. The next one and the last one is the concept of criteria subsumption. Okay. So when we compare the criteria, there might be cases where one criteria subsume the other, or they share some common elements. So criteria subsumption is if you have a test criterion C1, it subsumes C2 if and only if every set of test cases that satisfy C1 also satisfy C2, represented by this uh, figure here. So if you have the test requirement for C1 and you have the test requirement for C2, the set of test cases of C2 is inside C1, right? C2 is totally smaller than C1 and everything is consumed by C1. Then we say C1 subsume C2, or C1 is a superset of C2. The second case is if you have C1 and C2, you can map that the test requirement, the test cases from one criteria satisfy all the test cases, all the test requirement of another criterion, like this one, T1. The test case is satisfy T1. The test case for TR1's, sorry, let me start again. The test case that satisfy C2 criterion, the one that satisfy TR1, satisfy both TR1 and TR3 of C1. The one that satisfy TR2 also satisfy TR2 of C1. The one that satisfy TR3 satisfy TR5 of C1. And the one that satisfy TR4 also satisfy TR4 and TR6. This also subsume in the case that C2 or C1 subsume C2 in the way of one many to one. So the test requirement of C1 can be mapped. The test cases of the test requirements in C1 can be mapped to the test cases of the test requirement in C2 in a many to one manner. And the last one is when you have one-to-one mapping between the test case of the test requirement. This will be two-sided subsumption. So C1 subsumes C2 and C2 also subsumes C1 at the same time. And this is one-to-one subsumption. Okay. Okay. So let's apply this concept of subsumption to the existing example that we have, the candies. If you have two test cases, T1 and T2, we can see whether C1 subsumes C2 or not. Okay. So T1 satisfy C1 with 100%. Okay. It satisfies C2 also with 100%. The second one for T2, you satisfy C1 only 66.67%, but it satisfies C2 for 100%. But if you apply C1, okay. Okay, let's see this concept of subsumption in the example of candies that we have. So we want to check whether C1 subsume C2, okay? C1 is a flavor criterion. We have these test requirements. And C2 is a color criterion, and we have these test requirement. C1 will subsume C2 based on the definition is that when the test cases that satisfy the test requirement here also satisfy all the test requirement in C2. So let's see T1. T1 satisfy all the test requirement in T1 because it covers all the flavors. At the same time, it will also cover all the colors. So every time that the color criteria, the flavor criterion is covered fully by T1, covered fully by the test case, it will always fully cover the color as well, because the flavors that you have contains all the colors, right? So C1 will subsume C2 with one-to-many relationship. But it's not the other way around. If we want to check whether C2 also subsumes C1 or not, we can see that from this example of T2, by satisfying C2, you have 4 test cases. But however, these 4 test cases does not satisfy TR1, which is the test requirement of the flavor criterion. So this one is no. Okay. So C1 can subsume C2, but C2 does not subsume C1. All right. I hope you get the idea. So what is the good characteristic of good coverage criterion? The coverage criterion that is good should be easy to compute, okay, and it should compute the test requirement automatically. It should be efficient to generate the test value, and it should reveal as many faults as possible. Okay, so in the next few modules, we're going to discuss the combination of these coverage criterion into the test case design. The advantages of using these kind of coverage criteria is we can get fewer tests, but still very effective at finding faults. And we know we can find the test input that are more likely to find problems because we define all the test requirements and we want to cover all those test requirements as much as possible. If we think about the input space partitioning, the concept that we do also follow this kind of coverage criteria because we want to find the input that cover all possible partitions, right? All possible partition that you create from defining all the characteristics. This kind of coverage criteria also improve traceability, which means tracking of the test. Okay, we can answer why we create such test case because we can know that it answer some of the test requirement, and it also support regression tests by keep running the test over time, and you make sure that the software still work in the same way. And you can define this kind of coverage criteria to make sure that it still pass the criteria that you set. And by having this coverage criteria, we have the stopping rules. So we can answer how many tests are needed. It can be applied to test automation, and it makes the testing more efficient and effective. Okay. Last one, by having these kind of techniques, we can ensure that the software have high quality and high reliability. Okay. And next, we're going to discuss how we apply this kind of idea in actual practice. So to summarize, it is difficult for us to test all possible software inputs. So we define coverage criteria to make this kind of testing feasible. And we discuss the concept of coverage criteria and the concept of the coverage level. And that's all for this module. See you in the next module.